Deepak Chopra. You're watching One World with Deepak Chopra. And my very special guest is Dr. Neil Theise. You'll learn a lot during the next 20 minutes. But first of all, thanks for dropping by, Neil.
Thanks for asking.
So we've gotten to know each other recently quite a bit. You came to our Sages and Scientists conference. Yeah. I want to give our audience a little background. You're a pathologist, liver pathologist, interested in cell biology, professor at Mount Sinai. And you first came into my awareness when I saw this video that you had done after you attended the Towards the Science of Consciousness conference. And I learned that you're a stem cell researcher. So a lot of people don't know what stem cells are.
Well, and even more people think they know what stem cells are.
Yeah, that's right. So why don't you educate us?
Sure. So we generally talk about two classes of stem cells, embryonic stem cells versus adult stem cells. The idea is that a stem cell is any cell that has the capacity to renew itself as many times as it needs to, as well as turn itself into what are called more differentiated cell types. So in the embryo...
Just let me interrupt, if you don't mind.
Sure.
We all started out as a stem cell, right?
Right. Well, so
fertilized ovum is a stem cell.
Right, and this is where the definition kind of gets slippery, because I'm sort of at the radical fringe that says any cell actually has the potential to be a stem cell. There are very few cells that can't do that. And I think the principle that demonstrated that is the cloning of Dolly. And the cloning of frogs before that. But Dolly was a mammal. That's what made her pretty special.
And she was cloned from the skin.
No.
No.
No. No. Do you know why she was named Dolly?
After Dolly Parton.
Because she was cloned from a breast cell.
Yes.
And
right.
And I met Dolly, actually. And when I show pictures, everyone asks, "Is that a goat?" And I said, "No, that's Dolly the sheep. It's because they had shorn her to make a sweater for Dolly Parton."
I see.
That she autographed, and they auctioned that off for a children's hospital. Doing good in the world. So, yeah, so you can think that when a sperm meets an egg, the resulting cell is a stem cell. And it is. It's a kind of stem cell. But when they talk about an embryonic stem cell, the sperm and the egg unites, and then that divides, and then those cells divide, and then those cells divide, and eventually you get to the earlier structure of the embryo, which has two regions of cells. One's going to become the placenta and the umbilical cord, and the other one's going to become the actual body of the person.
The baby.
Of the baby. And those cells, they don't look like muscle cells or heart cells or brain cells or liver cells. They all look exactly the same. And those are called embryonic stem cells.
Pluripotential, as they say.
Yes.
Huh?
Yeah. Meaning they can
or any possibility.
Any possible cell can come from those. And then what happens in the embryo is those cells, as they start to divide, they respond to the other cells that are nearby and other molecules that are nearby, and they start to become your brain or your liver or your skin. But before that moment, they can do anything. And there were experiments.
They're uncommitted. They haven't made a choice, so to speak.
That's what we used to say. And this is kind of where things got exciting over the last 12 years. And my team was part of that, which was alternatingly frustrating and fun for me too. Interesting political biology.